Hi, my name is Ophir Chen. I'm from the B2B team within the Informatica Professional Services Organization. And today I'm going to talk about the ability to use B2BDT for mass generation of Informatica and specifically PowerCenter objects. I'll first speak about the challenge and the different options to resolve it, and then more specifically focus on the B2B option and how does it work in the context of the PowerCenter. And finally, I will have a short demo. Let's talk about the challenge first. So the challenge is that you need to generate a large number of mappings, workflows, and other PowerCenter objects, and they all share the same characteristics or maybe have some slight variations between them. The mappings could be simple, but they could be very complex. And manual effort is obviously very extensive. It's error-prone, and it will be very difficult to maintain. Imagine that you have hundreds of PowerCenter mappings, and all you need to do is to add one more new variable into it or populate some field from source to target. Doing it in an automatic fashion obviously is going to be much faster. There are three high-level ways to resolve the challenge right now. The first one is within the Informatica products. MAV and MEA stand for Mapping Architect Visio and Mapping Excel for the analyst. Both of them are giving you the capability to essentially build PowerCenter objects in some framework. And the main limitation is that you can only generate those objects that are supported by those products. If, for example, a workflow is not supported to be generated using those products, then you cannot generate that workflow. The second option is using Informatica's API called JMF, Java API for mapping framework. The main limitation with this approach is that it can only generate PowerCenter objects versus any other Informatica objects, like maybe Power Exchange, Data Map, or potentially B2B data transformation script, which you won't be able to generate through the JMF. The third option is probably the most robust one, in the sense that it is not limited to generate specific PowerCenter objects, as well as it could generate any feature within PowerCenter, whether it's the workflow, a variable, an attribute somewhere. And in general, it can generate any Informatica object as long as the product that uses it can do an import-export or as an import-export kind of a capability. Let's see how does the B2B option work in the context of PowerCenter. So first we would use some XSD representing PowerCenter repository, if you want. The XSD is not provided by Informatica, but there is an official DTD that can be received from Informatica and easily be converted into an XSD, which would later on be used within the B2B product to generate or read PowerCenter XML. The steps for generating that XML would be as follows. First, we would generate a sample mapping slash workflow in PowerCenter. We will create one real mapping end-to-end from source to any of the targets that it needs to generate. And then the second step to it will be to remove any non-generic part from the mapping workflow and so on. For example, the table name. If the table name changes between one mapping and the other, then let's make a generic table name. Same goes with any column of that specific table. We don't have to be worried about making it invalid. Later on, once the generator will add all the different fields and connectors, the mapping is expected to become valid again. The next step will be to export that sample template into XML using PowerCenter, and doing some analysis to figure out how does the XML look like, what kind of attributes within the XML we need to populate, what is static in the sense that it doesn't need to change between one template and the next one, versus what is dynamic, like table name, columns, a transformation that needs or doesn't need to be generated, and so on. And finally, once we understand the structure of the XML, we would go ahead and build within DT the XML from the metadata that could be any format. Examples could be a DDL representing that table, Excel, or anything else that we can come up with. Finally, when that process is done, we can run it, and then once it generates the XML can be imported into PowerCenter. Let's go ahead and see a short demo of how all those pieces come. Let's start first with the PowerCenter part. Over here you can see I've built a very simple PowerCenter mapping called mPerson. This mapping is essentially taking some data from a table called a person. The actual columns within that table, let's assume that they are first name and last name, and there is a constant column called ID, which we can assume that is being populated somehow. And all of that data goes into some sorter transformation, and then to a target table that looks exactly the same. In addition to that, there is another pipe over here that takes just the ID, and then it applies some logic in this expression to count how many rows were pushed to this expression, and populates another target, which is of type flat file with the rows count. As you can understand, this path is kind of static. The ID column is static, but the actual table name, the columns, are going to be dynamic. And for a different table, I want that mapping to have just different column names. Maybe the sort would act not only on ID, but also on any other column that may be a key within that table. Starting from this mapping that I've built, I'm going to the second step of it, which is to remove all the non-generic parts of that mapping. So for that, I went to the source definition, created a copy of it, and simply deleted the first name and last name, as well as the reference to the actual table name. I'm calling it with a static string dummy table. The same was done to the target. Instead of that TGT person, I have here a TGT dummy table with only the ID column that is, as I said, a static column. And finally, same process was done to the mapping itself. I renamed the mapping from mPerson to mDummyTable template, and then over here I'm just using the generic source as well as the generic target, and the rest of the stuff is generic as well. I removed everything that is not generic from the mapping. If I switch to the workflow manager, you can see that I have a similar workflow for both mPerson as well as mDummyTable template. And when I'm done with both of those, I can just go to the repository manager and do an export of the generic object, which is the WFM dummy table template. Okay. Once we did that, we can switch into DT, and there is a built-in assumption that DT is something that whoever is going to do it is going to be familiar with DT to a good extent. It's not going to be a trivial task to do within DT. But the DT has basically two steps. Step number one will take care of extracting the metadata from the metadata file and converting it into some XML representation that would later on be used to be mapped into the PowerCenter XML. This is a very simple example for the metadata format that I've created for this demo. As you can see, there is a table name thing over here, there is a description, and then there is a table, kind of a table that would stand for the different columns of that table, column names, type, precision, scale, and whether or not it's a key. I have another example over here for an address table, just different data. Let's take a look on the DT code that does that. So the parser over here is simply parsing one of those samples into an XSV, which I've built outside of DT as a root element called mdroot, table name, description, and then columns with name, type, precision, scale, and whether or not it's a key. I can test this specific parser, check the results. As you can see, it generates for me the table name, description, and it extracts the values of the column definition. As I said, you can come up with any format for the metadata that you want, as well as the XSV, and work with that. That's very flexible. The second step would need to merge between the template as well as the metadata that we just extracted. First, it would be using, as you can see, the XSV. There is a PowerMart XSV, and we can also see it from here. A PowerMart XSV is an XSD representation of the DTD that PowerCenter is referring to when you are exporting or importing a PowerCenter object. The XSV can be converted from the DTD using tools like XML Spy, or any other tool that you have that can do it. And the structure is fairly straightforward. You can have multiple repositories objects. They have some attributes. Within that, you have folders. And then you may have, using that choice, a mapping object or a workflow object, source, target, and so on. For a given source, as an example, there are different attributes that would represent the type of the source as well as the different columns of it. And there's no real documentation about the structure other than you can take a template, export it, and see how does it look like. Let's take a look at the process that actually does the merge between the metadata from step 1 and the PowerCenter template. So we start with this parser that points to the metadata file, similar to the one that I ran step 1 before. And the first step is capturing the entire input, and the second step is making a call to a transform by service, which essentially makes a call to step 1 that I showed you earlier, which was deployed to my service DB, and then it returns the same XML that we saw as the output. The next step is building just the file name. So it captures the table name, and it just suffixes that with a .xml, which will allow me to write every XML for a given metadata file into a different XML. The next step is really storing the template as a static string within the transformation. So what this one is really representing is the XML that I was exporting from PowerCenter. This is the XML, and all I did was to do a copy from the PowerMart object. You need to skip the first 2 rows. You need to skip the doc type over here, and copying the entire thing, pasting it within the set value over here. The XML would later on be loaded in the process, and the advantage of using the template is that there are many attributes in that XML and elements. As an example, the repository name, the version, the code page, and all those things that we see over here, that there's no point in trying to hard code them because they are very static. As an example, this target, which reflects the target rows count, doesn't change between one mapping and the other within that template. It's static, so there's no point in hard coding all those values. We can, kind of take it from the template, load it into memory, and then keep it as is, and focus only on changes to the dynamic data. As an example, within this source, the first source field is static, but all the other source fields would need to be representing the actual table that we are building it for. Let's go back to the DT code, and then the final step is build PowerCenter objects using the template. Within that, in order to load the PowerCenter XML as well as the metadata XML, I'm appending the 2 variables that are holding them into PC template, and then making a call to this run serializer that would take as an input this PC template, and using the source locator over here, it does one load of the PowerMart XML, and within the mapper, it would load the root element of the metadata XML that is coming from step number 1. Within the mapper happens all the logic of building the XML, and as you can see over here, I'm trying to do it using some naming convention that will allow me to understand which part is doing what. So in this one, it's building the source. The point to pay attention to here is the target locator by occurrence that is pointing to the choice under the folder and the sequence number. In this case, the source is set to be in the first iteration of the choice under the folder. As you can see in the schema of PowerMart, underneath the folder, there is a representation of a choice multiple occurrence, which basically says that any of those elements underneath can come in any order. And the repetition is defined on the choice versus on the source or the target or anything like that. So within DT, in order to work with or to scope one of those specific elements, we would have to use, in this case, locator by occurrence pointing to the choice, and then specifying the occurrence number. Occurrence number 1 would stand for the first element underneath the folder element, which is the source that I have interest in modifying. As you can see, the second iteration of the choice is this target, which is static, which means that the target that I would want to modify is the third iteration, and the mapping is actually the fourth iteration. So source is number 1 in this case, target is number 3, and the mapping is number 4. How do I build the actual source? I'm generating source fields, elements, for every colon element coming from the source, while populating, for example, the name, whether or not it's a key, the type, a field number, precision, and scale. The points to pay attention for over here would be mainly around the type and precision and scale, while the data type of the metadata, say, represents Oracle data types. In PowerCenter, especially within the transformation step, the data types are going to be different. So when one is a number in the source or target, in the transformation, it's the canonical data types / precision / scale that are driven from PowerCenter canonical format. So there needs to be some conversion. That is achieved by a set of lookups that some of them are defined over here. For example, Oracle to PowerCenter, or Teradata to flat file in some cases, Teradata to flat file, Teradata to PowerCenter, and you may change any of those or add to that as needed. For example, over here, number is being converted into double, but any entry could be added, modified later on. So as you can see, at the source level, there's no change in the data type. I'm not making a call to a transformer to convert the type from one to another. But during the mapping step, when I'm building the source qualifier, you will see that when I'm building the type for a given colon, I'm making a call to Oracle to PowerCenter type lookup. In addition, there is a need to change the case over here. Similarly, if we look at the precision and scale in definition, you can see that the logic is going through some alternatives, which is basically trying to convert or to see first whether there is a hard value for a given data type within PowerCenter. There is a hard value for its precision. And if there is no hard value for the precision, then it will try to take it from the spec. Or else, if there is no definition in the spec, then it will just take a default precision that is stored in some variable. Same goes with this scale. Okay, so we saw high level how do we create a source, a target, and then within a mapping, as you can see, it is broken down into the different transformations that needs to be created, specifically those that are dynamic. For example, there is no reference over here to the expression transformation that we had in the original template mapping, just because the expression transformation is static in our case. But the sort and the source qualifier are going to be dynamic. So if I'm looking at the source qualifier as an example, I'm building the name, the type of the field, the type of the port, the type of the colon, precision and scale, just like we did for source and target. And then the key point to pay attention to over here is that in addition to defining it, I'm also adding connectors. So in addition to, if I'm switching to the PowerCenter XML, in addition to the definition of a source field or within a transformation to a transform field, in addition to that, we need to keep in mind that we need to generate the connector element, which is essentially the arrow between one port and another port of transformations. And we can look at this example or those examples as for what attributes needs to be set and what is the convention. So there is a from field, the instance name, the type of it, and similarly on the target side of that arrow. So over here in our example, remember that we are in the source qualifier. The way for me to reference that source qualifier in transformation, unlike earlier when we did it with locator by occurrence, now we are within the mapping, and within the mapping, there is a sequence definition for the transformation versus the choice that we had before. Therefore, we can reference a specific transformation using a locator by key, and I'm making sure that I'm scoping my work to the source qualifier in this case, and in the sorter case, I'm going to that specific sort transformation. Then once I'm in that source qualifier, I have two groups over here, one for connectors from the source qualifier to the target dummy table, and then another one for every port that I'm adding, I need another connector from the source definition to the source qualifier. And each of them is being built in the same way, basically. It is referring the source object, the target object, and just adding the field name. Okay, so that's basically it. It will keep on building the mapping. Now let's see how does it actually work. So I'm running it against this metadata of address, and it created my XML. So now I can go to the repository manager and do import objects, and then just go to my DT transformation, and the output is being generated underneath the project folder. Within the result folder, there is an address.xml that got generated right now. I can say import it. I'm importing all the objects, And then keep in mind that some of the objects are reusable, or they are not changing between one mapping and the other. For example, the target rows count. So I can just say reuse of it and apply that to all conflicts. Doing the import, everything went fine, and I can go and check my mapping, source, and target. As you can see, there was a source created, target created for this address, and then I can open the mapping for address, and you can see that it added to the template the specific column names for address, populated that all the way, keeping the specifics of those columns as far as precision goes, data types, and so on. You can see also that in the sort, there was a logic that, if a field or a column is defined as a key, it makes it a key over here, which makes it part of the sort process. You don't have to, but that was just my definition. In addition to the mapping, obviously, we can go to the workflow manager, disconnect and connect, and we should also see that a new workflow has been created representing the address mapping or the workflow for it. And obviously, all the settings are being set according to the template. That's basically it. A couple of other points that I'd like to mention. You don't have to run it within DT for each of your templates. You can run it in a batch mode. You can set it here from sources to extract. Just give it a folder where all your metadata files located, and then give it some flag if you wanted to, so only those that are ending with a .txt. As you can see over here, I have 4 of those. And if I'll tell it to run now, then the output in my case will contain 4 XMLs, 1 for each one of those metadata files. All the results, I got these 4 that got generated. From an import perspective, you can use PowerCenter to import them either one by one or through the command line of PowerCenter to import all of them in some script. The next point that I'd like to stress here is that the mappings, as I said, could be very simple like the demo, but it could be as complex as you want. As you can see, this is a real mapping, a very complex one, which we've created a template for. And as you can see, it even became invalid because we disconnected so many things that, at the end of it, some of the objects were left unconnected. And then when we executed the generator, it created all those mappings for it, and obviously at that point everything becomes valid, and even works for a fairly complex mapping. The scenario that I'm showing over here is even a bit more complicated. The metadata for this scenario can be partially retrieved from a DDL representing that table, but some additional information is actually required from the user. One could build the mapping and then ask the user to fill in the actual information, maybe a filter condition, which port to sort by, or anything like that. But what we came up with was a different approach. The first step that I showed you earlier becomes a step that takes the DDL and generates from it an Excel that is later on being given to the user, and the user can play with that, and given the template of the Excel, it can make different switches, can play with different switches over here and put different values that would translate into maybe a variation of the PowerCenter mapping or the template that we came up with. As an example, if one would set a column over here to be a key or not, that could switch whether or not it is sorting based on that specific column within the sorter that we saw before. And then this Excel becomes the metadata for the step 1 that I was showing earlier. We need to parse it and pass the XML to the step number 2, which is being mapped into the PowerCenter mapping. This is it. If there are any further questions or queries about the approach, or how could you either do it yourself or use IPS to assist with that, feel free to contact me directly over the email or any one of the B2B team members within the IPS organization. Thank you.